Welcome to the first video of Chapter 5, which is over Section 5.2, Use Perpendicular Bisectors. So Chapter 5 again deals with triangles. We're going to start with talking about triangle centers, which is why we're skipping Section 1, but we'll go back to it. This chapter deals with triangles and algebra. It doesn't have as many proofs as last chapter did. So we should probably start by defining what is a perpendicular bisector. So a perpendicular bisector is a segment, ray, or a line that is perpendicular to a segment and bisects it. Okay, so let's draw an example. So if we have our segment, a perpendicular bisegment, let's choose a line for example, is perpendicular to the segment and bisects it, so cuts it into two congruent parts. So this is a very important point then. This point that bisects the segment, that cuts the segment into two congruent parts, is the midpoint. So that's a perpendicular bisector. Equidistant just means same distance. So two objects are equidistant from a third object if they're the same distance from that object. Okay, so the reason that we need these definitions is for the perpendicular bisector theorem. And this is the big theorem that's coming out of this section. The perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay, so let's look at the example that we already drew. It says if a point is on the perpendicular bisector. So that's the first thing that I'm going to do is draw a point on the perpendicular bisector. Okay, so I did that. Then it's equidistant from the endpoints. It's the same distance from one endpoint as it is from the other. So those two are congruent then. So let's look at the first example. It says, in the figure below, BD is the perpendicular bisector of AC. Find AD. Okay, so first thing I know is BD is the perpendicular bisector. So I'm going to draw some markings in. Perpendicular, so I'm going to draw a right angle, and then it also bisects. And I need to find AD. Well, if I knew what X was, I could substitute that in to find AD. So my first step should probably be to find X. Okay, so next I notice that point D is on the perpendicular bisector. So point D is on BD. Well, from the theorem above, I know that if a point is on the perpendicular bisector, it's equidistant from the endpoints. So that means this distance, AD, is going to be congruent to CD. Now, congruent, remember, just means equal. So I'm going to set the two equal. I have 3x add 14 is equal to 5x. If I subtract 3x, I get 14 equals 2x, and x equals 7. But remember, that's not my final answer. I need to find AD. Well, I know that AD is 3x add 14, so that's going to be 3 multiplied by 7, add 14, so 21 add 14. So AD equals 35. Okay, so let's move on. Example number 2, it says, in the figure below, which segments are of equal length? Well, there's something I need to tell you that I forgot to write, so if you could write this down. In the figure, HI is the perpendicular bisector of EG. Okay, so I showed perpendicular. It also bisects, though. Okay, so take a minute, pause the video right now, and see if you can write down the segments that are of equal length. I will give you a clue and tell you that there are 3 pairs of segments that are congruent. Okay, hopefully you took a minute to write some down. There are 2 pairs that should have jumped out at you right at the beginning. First, we know that FE is congruent to FG. These 2 are congruent. That's because they're both marked 25. We also know that EH is congruent to HG, because those I marked. Thirdly, point I is on the perpendicular bisector. Remember that if a point is located on the perpendicular bisector, it's equidistant from the endpoints. It's the same distance from the endpoints. That means this distance is congruent to that one. So lastly, I have EI is congruent to IG. So here were the 3 pairs that you should have come up with. Okay, then we're asked, is F on HI? Well, I know that point F is equidistant from the endpoints. By the theorem above, if a point is equidistant from the endpoints, then yes, it is on the perpendicular bisector. So I'm going to say yes, and I'm going to write out why. Yes, because F is equidistant from the endpoints, and the endpoints are E and G. Therefore, F is located on the perpendicular bisector. Which in this case is HI. Okay, so that's the first half of the theorem. If we could move on to the next page. Okay, we're going to start with a few more definitions. Okay, we say that objects are concurrent if they intersect at the same point. So for example, I have this line and this line that intersect, and then I have this line. We see all 3 intersect at this point, so we would say that all 3 lines are concurrent. The point of concurrency is just the point where the objects intersect. Okay, so this leads us to our next theorem. Our next theorem says the perpendicular bisectors of a triangle are concurrent. Okay, so every triangle has 3 perpendicular bisectors, 1 for each side. All 3 of those perpendicular bisectors are always going to intersect at the same point. And next. Okay, so next we have this point is equidistant from the 3 vertices of the triangle. Lastly, this point of concurrency is called the circumcenter. Okay, so this is the most confusing theorem probably from this chapter. So I think it would be best if we could draw this out. So I gave a space for a figure. So first let's draw ourselves a triangle. Okay, so we need all of the perpendicular bisectors. So all of those perpendicular bisectors have to go through the midpoint. So that's the first thing I'm going to do is find the midpoint of all the sides. And just eyeball it. Okay, now the perpendicular bisector also has to be perpendicular. So here would be one perpendicular bisector. Goes to the midpoint and is perpendicular. Here's the next one. Goes to the midpoint and is perpendicular. And then here's the last one. Sorry, I gotta do that one over. That did not turn out very as well as I had hoped. And then here's the last one. Perpendicular, goes through the midpoint. we'll notice that all three of those perpendicular bisectors intersect at the same point. If I had drawn it better, they would have intersect a little nicer. Okay, so this point right here is the circumcenter. Okay, it's equidistant from the three vertices. That means this distance, and this distance are all congruent. So I'm going to call these A, B, D. I'm going to call the circumcenter C. So I know that AC is congruent to BC and CD. Okay, the last thing that's important is that the circumcenter is the center of the circle outside of the triangle. So if we use this center as our circle, it's the center of this circle right here. So it's the center of the circle that's outside the triangle. Okay, so I know that this is confusing, so let's do an example. Okay, so example 3, it says, in the diagram below, point U is the circumcenter. Find the indicated measure. Okay, so the first thing I like to do is mark all the segments that are congruent. Well, I know that if U is the circumcenter, it's going to be equidistant from the endpoints, or from the vertices. That means this segment, and this segment are congruent. Okay, so I know that UQ is 14. That means US is also going to be 14. Okay, right now, pause the video and try B on your own, please. When you're finished, come back and we'll go over it together. Okay, so again, the first thing that I'm going to do is I'm going to shade over those segments that I know are congruent. The circumcenter is the same distance from all three vertices. So all three of these should have been congruent. Therefore, GA is 13. That's because BG is also 13. Something that you are going to notice is because these are perpendicular bisectors, you're going to have a bunch of little right triangles formed. So just remember that fact, that these are right triangles. And again, remember that this is the midpoint. So if this is 12, this is also going to be 12. Those are a few things that we're going to talk about in class. But hopefully you got B right. If not, that's okay. Bring your questions to class. So the two things that we're going to be doing in class tomorrow is determining if a point is on the perpendicular bisector or if a segment is the perpendicular bisector. And then we're going to find segment lengths, which is what we just did. Again, if you have questions, bring them to class, please. Thank you.